The difference between nuclear charge and effective nuclear charge is that nuclear charge is just the amount of protons in the atom. However, effective nuclear charge is the number of protons acting on the last shell of electrons in the atom. You can increase effective nuclear charge by having full shells or more full than they were without creating a new shell. As the effective nuclear charge in an atom increases, atomic radius decreases, because there is more attraction from the electrons to the nucleus. And as effective nuclear charge decreases, the atomic radius increases. Well, first of all, it's not talking about the effective nuclear charge, but only the nuclear charge, which means that francium has 87 in atomic mass and fluorine has 9 in atomic mass. And this means that francium has much more electron shells than fluorine, which makes the atom bigger, so the atomic radius is larger than. The more shells an atom has, the easier it will be to take electrons from it, hence less ionization energy, so more atomic radius equals less ionization energy. If bromine has more protons than fluorine, means it also has more electron shells than fluorine, which makes it easier to take an electron from bromine, so it means the ionization energy is lower than fluorine. More electron shielding reduces effective nuclear charge, which is the negative correlation, and increases atomic radius, which is the positive correlation. In the result, it's the result of electrons in the lower shell absorbing the nuclear charge of the protons, which makes it increasing when going down a group because there are more shells, so that electron in the less shells will experience less charge than the ones. The ionization energy of gases is greater than that of metals because of the full last shell. It's full of the valence electrons. The atomic radius is smaller and the shielding is less too, since shielding and atomic radius have a correlation that the less shielding, the less atomic radius there is. This graph represents the relationship between ionization energy and atomic radius. As you can see, the smaller the atomic radius is, the higher the ionization energy is. And as we see, as the atomic radius increases, the ionization energy decreases. So this is a relation. The ionization energy decreases as the atomic radius increases. The rule I've created for elements when approaching F on the periodic table is that the atomic radius keeps getting smaller since it's going right on a period. So as the atomic radius decreases, the ionization energy increases. As we go right in the periodic table, as the rule I've created for ionization energy, that is, as you go right, the ionization energy increases, the electron shielding decreases, and the shielding effect decreases. This is because there are more electrons acting on the last shell, which means there are less electrons to be taking the charge in the inner levels.